While the eruption of Iceland's Reykjanes volcano is still ongoing, a major development occurred at a far more explosive volcano in the country. As a result, it is now almost certain that the Hekla Volcano will erupt by 2026, with the warning sign suggesting it could erupt far sooner than this, perhaps even within a month from now. I am making this assertion based on a piece of circumstantial evidence, one that seems to repeat itself before each of Hekla's recent eruptions, per comments from locals and farmers that are familiar with the region. What I am referring to is that the Reykjanes River, which is directly fed water from springs that bubble up through the Hekla volcano, has, as of August 29th, become completely dry. This river has become dry anywhere from days to multiple years before each of Hekla's recent eruptions, with water only coming back to the river in the hours to days before an eruption commences. So, why exactly might this be occurring? Although this is uncertain, I would wager that the disappearance of the water from the river relates to variations in the nature of ground deformation or uplift which this stratovolcano is experiencing. For context, Hekla is fed by two magma chambers, one at 12 km depth and the second at 6 km depth. When magma fills the 12 km depth magma chamber, it generates a broad area of uplift, causing groundwater which beforehand traveled along a pre-existing fault line to the surface to suddenly flow elsewhere, causing the Reykjanes River to dry out. Eventually, magma moves to the 6 km depth magma chamber, generating a narrower center of stronger ground uplift, likely due to that magma chamber's smaller size. As a result, when this occurs, the ground which fed groundwater via springs at the Reykjanes River actually subsides to an extent, just enough that the river begins flowing once again. Once that occurs, it could be as little as 20 minutes or as much as several days before an eruption begins at Iceland's second most consistently explosive volcano of the Holocene epoch after Katla. Although the groundwater has not yet returned, meaning current evidence suggests an eruption will occur within 2.5 years of this video being posted, you might be wondering why I am making such a strong inference based on just one, not completely scientific piece of circumstantial evidence. After all, on a tier list of various types of evidence involving a volcano during a period of hypothetical unrest, circumstantial evidence ranks near the bottom. My justification is that since each of the more than 1,000 active and potentially active volcanoes on Earth are distinct, at some locations changes to specific geothermal or groundwater sources can actually tell a great deal more or less depending on the volcano. For example, at Hawaii's Mauna Loa Volcano. As strange as this might sound, a driveway that a viewer of mine has is where this feature is situated. This viewer noted that a gas seep or fumarole appeared on his driveway during the months leading up to the 2022 eruption, likely due to magma reaching a sufficient height in the underlying magma chamber that had started to feed this vent. Yet, after the 12-day-long Mauna Loa eruption during parts of November and December ended, this gas seep became inactive. A similar series of events occurred before Mauna Loa's prior 1984 eruption, suggesting that this tiny gas vent is an indicator of what stage the volcano is at. Going back to the Hekla volcano, well, yes, it does experience ground deformation along with other signals before an eruption occurs. These indicators only sometimes begin between 23 and 80 minutes before an eruption occurs. This likely has to do with how unusually fast magma ascends from 6 km depth to the surface, being propelled by the expansion of gas in the magma. In other words, Hekla is highly unpredictable, often showing no obvious short-term signs of unrest until as little as 20 minutes before it ends up erupting. Therefore, what would be considered as a less important sign of unrest at any other volcano is deemed highly important at the Hekla volcano, as it is one of the only existing signals to occur longer than an hour before an eruption begins. As a final note, I want to remind everyone that not every time the Reykjanes River goes dry means that an eruption has a 100% guarantee of occurring. A similar series of events could also theoretically occur due to non-volcanic reasons, or even due to a magmatic intrusion reaching shallow depths but failing to reach the surface. While we cannot predict the size of Hekla's next eruption, it probably will rank on the Volcanic Explosivity Index as a 2 to a 4 and last for at least 1 week.